Okay, everybody, I'm trying to contain my excitement right now over what I'm about to show you. So what you saw just a couple of minutes ago was a traditional data center hall, traditional racks, traditional cooling systems. Let's say an environment that supports between 10 and 15 kW per rack. But now what if you have an AI system? What if you have all these new DGX systems that are coming out from NVIDIA? Well, you're going to need a little bit of a different type of architecture to support this. I'm going to share that with you. So these are EGX H100 units. If you take a look at this rack, there are six of them inside of here. Each of these units is 6U and has H100 GPU cards inside of them. Each of these takes up 10.2 kilowatts per rack. Whoa, whoa, whoa. 10.2 kilowatts per rack. There's no way you could put six of these into a traditional type of architecture because those racks just can't handle the density because there's so much heat and power requirements. So what do? You turn to liquid. In this case, this is a rear door heat exchanger. Think like a car radiator, but in the back of a actual rack. Let's take a look at what that looks like. So inside of this environment, actually back up a little bit. Right now, these DGXs are running live data models, actually running on my platform, Apollo. And so right now we have real customers training their models in their data. Now, what's really fascinating about this is the actual architecture. This is the Motivair rear door heat exchanger. You can see it operating beautifully right behind me. And this is a 60 kW rack, which means that we are capable of putting upwards of 60 kilowatts in this entire rack. And again, it's a little bit taller than normal. Remember, you can go higher than a traditional 42 unit rack, which is exactly what we did here. But in this situation, Scott Data Center is capable of supporting 6 DGX units in a really cool new kind of reference architecture to support all of the new kinds of AI demand, model training, inference training. Now, I'm going to share one more really cool thing with you. How do you get the water, the actual manifold, into this architecture? Now, the cool thing here is it's right over here going into the ground. Now, sadly, it's already inside the rack. You can't see it, but maybe you can because I've got an extra one right over here. Let's go take a look at it really, really quick. Okay, everybody, you are going to get a chance to see something very, very, very special and kind of rare because these systems are usually what you saw already inside of a rack. This is the Motivair water manifold, basically that allows the distribution of water into those rear door heat exchangers. Now, each one of these is capable of supplying each one of those 60 kilowatt racks. If you take a look right here, this is the in and this is the out that goes into the actual racks. So again, inlet here and then out into each individual rack. So this one little manifold right here can support 8 of those 60 kW a piece Motivair racks with 6 DGX units inside of them. So again, this is a critical piece of infrastructure that goes into those Motivair racks. And I'll show you what it looks like. That is right here. And you can actually see some of the connectors right below over there supporting this Motivair rack. Now, again, what you're seeing right now is actually pretty rare because, again, that manifold right over there is usually hidden inside of this infrastructure. So this piece of environment is absolutely critical. And you can see it's not just for one rack, but for multiple ones to help enable things like scale and more AI compute at a very high density level. Hey, quick bonus video on the topic of liquid cooling. We just saw Motivair, but there's not one, but there's 2 different types of rear door heat exchanging cooling methods. This one is housing the storage environment, and it is made by Vertiv. So let's take a quick look at what this infrastructure actually looks like. Because back here, it's a little bit different, but there it is. This is the Vertiv rear door heat exchanger architecture that supports the storage environment in this kind of ecosystem for AI specifically. Now, this is about like 30 kW per rack density instance, while this one supports upwards of 60. So I'll step back a little bit so you can actually see both. So these are 2 different types of rear door heat exchangers, all designed and built to support the next generation of AI and honestly, the next generation of density. Really cool stuff.